Given ABCD is a parallelogram with these coordinates, we're going to find the coordinates of x, which is the intersection of the diagonals. So, diagonals of a parallelogram bisect each other, which means they're going to intersect at the midpoint. They're going to have the same midpoint, and that's going to be where they intersect. So we just need to find the midpoint. So to find the midpoint, we're going to use midpoint formula, which is x plus x divided by 2, y plus y divided by 2. Pick either points AC or BD. So I'm going to take A and C. So midpoint is going to be 2 plus 8 over 2, and then 4 plus 0 over 2. So that's 10 over 2, which is 5, and 4 over 2, which is 2. There's the midpoint. That's where they intersect. To find the area, you're probably going to want to plot them a little bit. It is a parallelogram. So area of a parallelogram is base times height, but the height is perpendicular to the base. So if we plot these out, 0, 0, 8, 0, 2, 4, and 10, 4. We need the base times the height to get area. The base will take the easy measurement going straight across from D to C. That's 8. The height just needs to be perpendicular to that. So it's going to go straight up. So we'll go straight up to A, and that'll be our height. So the height, we can just count it out. 1, 2, 3, 4. Area is base times height. 8 times 4, 32. So this must be a rhombus because it says find the length of a side of the rhombus. So we can go any 2 points as long as we don't take diagonals. So we can take L and I, we can take I and O and N, either one. Doesn't really matter. It should get us a rhombus. And we can do distance formula. Looks like O and N would be pretty easy. So we take 5 minus 0, it's 5. Squared, 25. And 0 minus 0 is 0. Squared doesn't do anything, so we just have square root of 25, which is 5. So the length of the side of the rhombus is 5. If you wanted to make sure and justify that it is a rhombus, you can check these things. So if the diagonals are perpendicular, I'll plot it out so we can take a look at it. So there's all of our points. So the diagonals are perpendicular. You could check the slopes of those diagonals and see if they're opposite reciprocals. This one goes up 4 over 8, rise 4 over 8, or 1 over 2. The other one goes down 4 over 2. down 4 over 2, or negative 2 over 1. Those are reciprocals. They are one positive, one negative, so the diagonals are perpendicular. That's true. L, O, and I, N. Let me label these. L, O, and I, N have slopes that are opposite reciprocals. So that's what we just checked. Those are the diagonals. Yes, they have slopes that are opposite reciprocals, so yes. All four sides have a length of 5. Yeah, that's what we found in part A. That's true. All four sides have a length of 6. No, they all had a length of 5. So it's 1, 2, and 3. School is building a fenced-in garden represented below. If each unit represents 1 yard, label the length of each segment of fencing and calculate the total length of the fence to the nearest yard. So, do the easy ones first. This has got a length of 3. This has a length of 3. This has a length of 6. Then you can do the more difficult ones. Turn that into a triangle. That's 4 and 3. 3 squared plus 4 squared. It's 9 plus 16. It's 25. So that's square root of 25, which is just 5. Turn that into a triangle. You get 2 and 3. So 3 squared plus 2 squared. That's 9 plus 4. 13. Square root of 13 is that side length. And then you add them all up. Calculate the total length of the fence to the nearest yard. So we will round it to the nearest whole yard. So if we do that, then we're adding 3 plus 5 is 8, plus 3 more, 11, plus 6, 17, and then 13, that's going to round up, I think, that'll round up to about 4. So we're 11, 17 plus 4 is 21, and those are yards. Quadrilateral WXYZ is a parallelogram. So let's draw a parallelogram. W, X, Y, Z. XZ, the diagonal, is perpendicular to WY. So if those are perpendicular, those are the diagonals, that means it's a rhombus. Even though it doesn't look like a right angle, I'm going to say it is. That is a rhombus. Also, then we have XWY, that's this angle, is complementary to WYZ. WYZ. That's labeled wrong. That's supposed to say YWZ. So if these two angles, not that one, if these two are complementary, that means it adds to 90 degrees. So that means that's a right angle right there. So if we have a right angle in the corner and it's a rhombus, so if it's a right angle, it's a rectangle, and it's a rhombus. So is it a rectangle? Yes. Is it a rhombus? Yes. And if it's both of those, that means it's a square. So we'll go through this proof. MH and AT, these are supposed to be diagonals, MT and AH bisect each other. That means that MX and TX are congruent, and AX and HX are congruent. Because bisect means they cut each other in half, two equal pieces. Definition of bisect. Then our next reason is vertical angles. So let's look in this and let's get some vertical angles. And we're about to prove triangle MXH. So let's get an angle in triangle MXH. That'd be a vertical angle over there to AXT. Angle MXH is congruent to angle TXA. So now the triangles are congruent because we have two sides and the included angle. So side, angle, side. And then the rest of the proof is done for us. So the angles are congruent, which makes the two sides be parallel because of alternate interior angles. In quadrilateral ABCD, the consecutive angles are supplementary. So if consecutive angles are supplementary, that means it's a parallelogram. So if it's a parallelogram, then we have a whole bunch of things that are true. Opposite sides are parallel, opposite angles are congruent, diagonals bisect each other, opposite sides are congruent, and consecutive angles are supplementary. So both diagonals are angle bisectors. That's not true for a parallelogram. That's actually true for a rhombus. And we don't know that this is a rhombus. So that's false. The diagonals bisect each other. That is true for parallelograms. Both pairs of opposite angles are congruent. That's true for parallelograms. In quadrilateral prom, PR is congruent to OM, and PM is congruent to OR. So let's draw that out. P, R, O, M. If PR is congruent to OM and PM is congruent to OR, those are opposite sides. If opposite sides are congruent, that means that this must be a parallelogram also. And if it's a parallelogram, we have the whole list of things that's true. Both pairs of opposite angles are congruent, yes. Both diagonals bisect each other, yes. Both diagonals are equal. No, that's only true for rectangles. We don't know it's a rectangle.